Today's lesson is going to be over analyze graphs of polynomial functions. The first thing you need to keep in mind with the graphs of polynomial functions is that you will see different shapes. You might see a U. You might see what I call a form of an S. You might see something that looks like a W. So there are multiple ways that you can see a graph of a polynomial function. In your graphs of the polynomial functions, you will have the local minimum, and the local minimum is simply the lowest parts of the graph. So like on this one, your local minimum would be right here and right here. The local minimum is the y-coordinate, a y-coordinate of a turning point if the point is lower than all nearby points. We also will come into contact with local maximums. The local maximum, again, if I'm looking at this form or this shape of a graph, the local maximum is going to be this part right here because it is the y-coordinate of a turning point if the point is higher than all nearby points. We have talked about minimum and maximums when we were looking at a parabola. In a parabola, you're only going to have one or the other, and you only have one of them. You won't have two minimums or two maximums. You will only have one. And for instance, this parabola right here, your local minimum would be this point. Now, having this information, we can now go and try to look at a graph and see what our local minimums and local maximums might be. What we are fixing to do is we are going to graph f of x equals 1/5 times x minus 3 squared times x plus 2 squared. Once we graph this, then we're going to look and see what our local minimums and local maximums are. And that it will be the analyzing graphs of polynomial functions. The first thing I want to do is take note of the fact that this is in the form of f of x equals a times x minus p times x minus q. Remember that this form right here that I just wrote is the form of the x-intercepts for a polynomial function. And so because of that, I can see that my one x-intercept is going to be at 3, and then one x-intercept is going to be at a -1. For all the other points, I want to go ahead and make a table. Alright, so I'm going to draw an XY table I have my X and Y. I want to use a -2, -1, 0, 1, 1, 2, 3, and 4. So what I'm going to do is solve the original equation for each one of my x's I just placed in my table. So I'm going to start with 1/5 times a -2 minus 3 squared times a -2 plus 1 squared gives me 1/5 times a -2 minus 3 is a -5 squared, and then a -2 plus 1 is a -1 squared. We know that a -5 squared is a positive 25, and that 1 squared is 1. And so we can say 1/5 times 25 will give us 5. So I'm going to go ahead and put 5 as my y. I'll solve it again. 1/5 times a -1 minus 3 squared times a -1 plus 1 squared. Again, I'm going to keep my I'm going to keep my 1/5. A -1 minus 3 gives me a -4 squared. And a -1 plus 1 gives me 0 squared. So I have 1/5 times 16 times 0. And we know anything times 0 gives us 0. So therefore, I now have my next answer. We're going to go again. 1/5 times 0 minus 3 squared times 0 plus 1 squared. Again, I have 1/5 times 0 minus 3 is a -3 squared, and then 0 plus 1 is 1 squared. So I have 1/5 times 9 times 1 gives me 9/5. So there is my third answer. I'm going to go 1/5 times 1 minus 3 squared times 1 plus 1 squared equals, again I keep my 1/5. 1 minus 3 gives me a -2 squared. 1 plus 1 gives me 2 squared. So I have 1/5 times 4, because a -2 squared is 4, times 2 squared, which is 4, gives me 16/5. So I am halfway done. I've got 1/5 times, again I'm going to use 2 minus 3 squared times 2 plus 1 squared equals, I have 1/5. 2 minus 3 gives me a -1 squared. 2 plus 1 gives me 3 squared. So now I have 1/5 times 1 times 9, because of 3 squared. So again I have 9/5. I have 1/5 times 3 minus 3 squared times 3 plus 1 squared equals 1/5 times 3 minus 3 is 0 squared, and then 3 plus 1 is 4 squared equals 1/5 times 0 times 16. Anything times 0 is 0. The last one, I'm going to put up here, I have 1/5 times 4 minus 3 squared times 4 plus 1 squared equals, again, 1.
Devontae, Gibson, call the office, please. Devontae, call the office, please.
1/5 times 4 minus 3 is a -1, so a -1 squared is 1, times 4 plus 1 is 5, and 5 squared gives us 25. So 1/5 times 25 gives us 5. At this point, because now we have all of our x's and y's, so we can plot every one of these points. So we're going to go over to our graph, and we are going to plot our points. The first one, again, it's a -2. Remember, the -2 is to the left of the y-axis. So I'm going to go over 2, and it says up 5 because it's a +5. 1, 2, 3, 4, 5. So I'm going to place my point right there. The second one says a -1, 0. So again, I'm going to go to the left of the x-axis to 1, and I'm going to plot my 0. That's one of my x-intercepts. The third one says 0, which is on the origin, and it says 9/5. So 9/5 is going to be almost 2. So I'm going to plot my point right here. The next one says 1, so I'm going to go to the right of my x-axis, 1, and it says 16/5, which is 3 1/5. So I'm going to go up 1, 2, 3, and then go just a little bit higher. So 3 1/5. My fourth number, my fourth plotted point will be at a +2. So I'm going to go right of the y-axis twice, 1, 2, and I'm going to go up to a little, almost to 2. So I'm going to, again, it's going to be about right there because that'll be 1 4/5. My my sixth point is 3, 0. So I go to the right 3 times, 1, 2, 3, and I plot my point. Again, that is an x-intercept. And the very last one, which is 4, 5, I'm going to go to the right 1, 2, 3, 4, and I'm going to go up 1, 2, 3, 4, 5. And again, I'm going to plot my point. At this time, I want to connect all my plots, my plotted points together. And so I intend to do a very soft line until I can see pretty much what it's going to look like. And then I go back to make it a little better. Because I want to make sure that I get through all my points without much of an issue. So now I can go back through and I can make my curve as smooth as possible. And again, you want to keep your arrows that way. You can see that it continues to go up. Now, what we've done so far is simply graphed the equation of 1/5 times x minus 3 squared times x plus 1 squared. What I want to do is look for my local minimums. Remember, the minimums are the lowest points on your graph. And so my minimums are going to be right here because there's nothing that goes any lower than that. So I can say my local minimum is a -1, 0, and 3, 0. My local maximum is going to be the high curve. And so that's right here. And that was at 1/16/5. And so now we have analyzed the graph of 1/5 times x minus 3 squared times x plus 1 squared. We plotted all the points that we found. We found our curves. And then we noticed that our local minimum is the lowest, which was at a -1, 0, and 3, 0. And then our local maximum was the highest curve, and that was at 1/16/5.